What is calculus? The word calculus comes from the Latin word calx, which means pebble. A fun fact: people in ancient times did arithmetic with piles of stones, so a particular method of computation in mathematics came to be known as calculus. Calculus is a mathematical discipline that is concerned with functions, limits, derivatives, integrals, and the like. The key ingredient in calculus is the notion of infinity. The creation of calculus around the 1670s is credited equally to Sir Isaac Newton of England and Gottfried Wilhelm Leibniz, a German. It was developed out of a need to understand continuously changing quantities. There are two main branches of calculus: differential and integral. Differential calculus is concerned with continuous change and its applications. It is a branch of mathematics dealing with the concepts of derivative and differential and the manner of using them in the study of functions. Differential calculus is based on the concepts of real numbers, functions, limit, and continuity. The second side of calculus is integral calculus, which deals with integrals. Closely related notions of this are the indefinite and the definite integral. The two branches are intimately connected to each other and form the foundation of mathematical analysis.
In the field of business and economics, credit card companies use calculus to set the minimum payments due on credit card statements at the exact time the statement is processed. Economists use models to describe various functions like the supply and demand graph in the economic marketplace. Differential calculus is applied to original supply and demand models to determine how different factors will shift the lines representing supply or demand in the economic market. Many economists use differential calculus when measuring economic information. Business owners can use this to help forecast expected sales for their business operations. The use of economic analysis in a business is an important management tool when making business plans and decisions.
In the field of architecture, calculus is used for the structural analysis and structural design of a building. It is also used for the lighting analysis and design inside buildings. It is also used for the design and planning of vertical transport in buildings, the climate analysis for the planning and design of HVAC systems, advanced climate analysis for green buildings and building complexes. Computations regarding the cost and financial feasibility of real estate projects, including statistical assessment of building value, utilizes calculus. Calculus is used to improve the architecture not only of buildings but also of important infrastructures such as bridges to create sturdy and unique designs. For example, though many buildings have arches with perfect symmetry, calculus can be used to create archways that are asymmetric along with other odd shapes that are still durable.
In the field of biology, derivatives are used to find the rate of muscle contraction and dissolution of drugs into the bloodstream. Calculus computes the sensitivity of drugs and voltage of brain neurons after a given time interval. Calculus can track the growth of bacteria. Integration, a concept in calculus, is used to find the change of temperature over a time interval from global warming.
In the field of engineering, civil engineers use density and volume to find the weight of an object. In structural engineering, calculus is used to determine the forces and complex configurations of structural elements. Structural analysis relating to seismic design requires calculus. In a soil structure context, calculations of bearing capacity and the shear strength of soil are done using calculus. In mechanical engineering, calculus is used for computing the surface area of complex objects to determine the frictional forces and to calculate the power provided by a battery system. For aerospace engineering, thrust over time calculated using the ideal rocket equation is an application of calculus. Analysis of rockets that function in stages also requires calculus, as does gravitational modeling over time and space. Almost all models of physics utilize calculus, especially those of astronomy and complex systems.
In the field of technology, calculus is used in rendering, which is the process of turning a 3D model into a 2D image, requiring the simulation of light bouncing around in a scene as it finally makes its way to the camera or viewpoint.
In the field of astrology, astronomers use calculus to study the different motions of planets, meteorites, and spaceships. The most common use of calculus in astronomy and physics is to find the rate at which the position of a moving body changes over time. The laws of planetary motion used most commonly by astronomers to study and calculate orbits are derived using calculus. For example, in order for a rocket to be sent into space or a satellite into orbit, astronomers must use calculus to figure out how much fuel the rocket or satellite needs to accelerate to the correct velocity to break through the atmosphere. Calculus involving differential equations is also used in designing telescopes, mirrors, and lens.
In the field of medicine, calculus is used to determine the blood flow in an artery or a vein at a given point in time. It is also used to find the amount of blood pumped through the heart per unit time and can help determine how fast a tumor is growing.